All right, so the 1 heart quiz number 3. Solving this equation. So we decided when we were doing these in our notes that not the only way, but a handy way of doing these problems that are full of fractions is to do what? What did we decide our strategy would be? A good strategy would be, Lauren?
Get a common denominator.
Make all the denominators the same, because once you get them all the same, then you can get rid of them, right? So 7, 3, and 2, what's going to be our common denominator? Isn't it going to have to be 42? 7 times 3 times 2. So 42, so this one's going to be multiplied by 6. This one's going to be multiplied by 14. And this one's going to be multiplied by 21. All right, Charlie, does that make sense to you? Okay. So we have all the denominators now are 42, so I'm going to forget those. So I have 18 minus 28x equal distribute 21x plus 21. So let's see, if I add 28x, I'm going to have 18 equal to 49x plus 21. Subtract 21 and divide by 49. So negative 349 is what I got. All right, time for one more question. Anybody else have a question about one of the quiz problems? Yes, Lauren?
Number 1 on the 2-part quiz.
2-part quiz. Number 1 is an exponent simplification. All right, so what did you do first? There's lots of ways to start. How did you choose to start?
I decided to square everything to the second power.
So 16 x to the 14th, y to the negative 6 over 36 x squared y is 10. Okay, then what?
Then I simplified the variables. Like x, did the.
So x to the 14th over x to the 2nd is going to give me x to the 12th. And these guys are coming down, so that's going to give me y to the 16th on the bottom.
I think that's where I did it wrong. I think I kept it negative.
Okay, so you can subtract and get y to the negative 16th, but your answer can't have negative exponents, so you're going to have to move that 16 to the bottom. And then, of course, we got to deal with our 16 and 36. So those are both divisible, I guess, by 4. So that would be our answer. All right. Okay, let's put that away. And come in for office hours if there's still stuff you have questions about. We are going to continue working in P5 today. Hopefully get it done. We'll see. Last time we were together, we did problem 3A, didn't we? Yeah. Last time. So we're ready for 3B, exactly the same thing, so this will be some good review for us. We need to complete the square. All right, so look at our previous example or dig back in your memory. How do we complete the square? What do we have to do? Mom, we went through this the other day. Somebody remembers.
Don't you have to add the 2 over
Yep,
first?
you gotta get rid of that 2. That 2 is not the right number to have in that spot. I need to find the right number. That's like, it's called completing the square. That process, that's gonna give me the right number, so this will be a perfect square right here. So, who remembers how I find the right number, Katie?
You would divide that -4 by 2 and then square it.
Exactly, so 4 divided by 2 is 2, squared is 4. So the right number is 4. Okay, so now this is a perfect square. What is it, Van?
How did the 4x become negative?
Shouldn't be, thank you. That doesn't impact this number, right? But it would have impacted this, so thanks for catching that. All right, so what goes in this parentheses? What square is this?
X plus 2.
X plus 2, perfect, and equals 6. What's next? Nate?
Well, you're gonna square root both sides.
Yep.
Get X plus 2.
And then when I do that, I gotta remember plus or minus root 6 over here. We can't forget the plus or minus. And we'll move our 2 over, and that's it. Don't try to add those together, they don't add. You can't combine those. So just leave it like that. All right, so that's a good warm-up problem. Now we got a little bit more of a challenge here. What do you think about this one now? Katie?
Would you start by trying to get rid of the 2 in front of the X squared?
Exactly. Very good. When we complete the square, that can't be there. Remember, our goal is to come up with a parentheses that starts with an x. X plus something or x minus something. That 2 is gonna screw that up. So how do you think we're gonna get rid of that 2? What would make sense? Divide. And yes, fractions are part of our life, we're just gonna have to deal with it. No help, I mean, there's no way to help it. I would suggest you leave it as a fraction and not change it to a decimal. It's easier to work with. All right, now what? Yep, so x squared minus 2x equals -3/2. This problem's crazy. Now, what's gonna complete the square? And -2 divided by 2 is 1, and 1 squared is 1. So I'm gonna add 1 to both sides. Everybody catch that? Huh?
Do you mind repeating that?
Half of 2 is 1, and 1 squared is 1. So that's how I get that number. What parentheses is this? What perfect square is this guy? X minus 1 equals -1/2. Oh boy. We got this. What do we do now? Square root. So we have x minus 1 equals plus or minus the square root of -1/2. When you square root a fraction, you square root the top and you square root the bottom, right? So I have x minus 1 equal plus or minus. What do I do with the square root of -1?
Don't you multiply by square root of 2?
Well,
Like,
eventually I'm gonna have to do that, but tell me, what is the square root of -1? You know this. That's not 1. Square root of positive 1 is 1. What's the square root of -1? Who remembers? That's your I. So I'm gonna have an I on the top and a √2 on the bottom. Now, Robbie, you're exactly right. I can't have this on the bottom. So now, told you this problem was something else. Gotta multiply top and bottom by square root of 2. So now I have plus or minus I root 2 over 2. And then finally, I'll get that 1 moved over. And here is our answer. What a big problem that was. So let's stop for a second. But the point of the problem was to complete the square. So we divided by 2, completed the square, and then we ran into this yucky arithmetic. Does everybody now remember that the square root of -1 is I, the imaginary unit? And you're not allowed to have a radical in the denominator, so we rationalize it by multiplying top and bottom by it. Wow. All right, one more. One more. This is gonna be another one that looks kind of dangerous. What do you think we'll do first to solve this one? Divide everything by 3. So x squared equals 3x plus 4.
Subtract 3x over.
So x squared minus 3x. And normally we shoot for getting 0, but Robbie says that'd be a waste of time because I just want that 4 to stay over there, right? If I'm completing the square. Okay, here we go. Half of 3 squared. That's what I'm gonna add to both sides, right? I take half of this number and square it. So what's half of 3 squared? What's that gonna end up being? Meg?
9/4.
9/4. Square the top and bottom. That's exactly right. Don't second guess yourself. That's exactly right. And then Kendall, what is that gonna give me here in my, when I write this now as something squared? What am I gonna have in here?
X. Is it the 9/4 that go in there?
Minus, it won't be 9/4. It'll be what squared gave me 9/4
3.
over.
2.
Yep, that's it right there. That's what goes in there. So what goes in there, when you take half of your number, that's what goes in there, because you square it to get the 9/4. What's on the other side? Well, we need a common denominator. I heard somebody say it, 25 over 4. Get a common denominator when we add fractions. All right, we're square root both sides. So x minus 3/2 equals what? Plus or minus 5/2, perfect. So x equals 3/2 plus or minus 5/2. This is gonna work out great. What's 3/2 plus 5/2? 8/2 or 4. And what's 3/2 minus 5/2? Negative 2/2 or negative 1. A lot of arithmetic there. Anybody have a question about it?
How do we get 25 over 4?
This is 16 over 4.
Okay.
And 16 and 9 is 25. We gotta know how to complete the square, guys. Make sure you know how to do that process. Half of your x term squared. All right, next section says we're gonna solve using the quadratic formula. Uh-oh, the quadratic formula. Maybe I should write that down. Anybody know it? I heard a negative b, yep. Plus or minus. B squared minus 4ac. All over 2a. All right, what are we gonna do to get this ball rolling? I swear I'm not a smoker. Okay. Oh. Should I distribute here? Okay, I have no idea. What do you think? Did I do that right? I don't want to start in if I don't have it.
That's what I got.
That's what you got, perfect. That's all it takes. Anybody have a question about getting that? Getting this? So if we're using the quadratic formula, right there, we need to figure out what A, B, and C are. So for this problem, because those are the numbers we're gonna plug in, for this problem, what's A? B is, actually B is -8, and C is -10. We gotta use the signs. Please notice, there are no x's in the formula. So you don't bring along the x's. The A, B, and C are just the numbers. Alright, so here we go. X equals 8. 8 squared minus 4 times 3 times -10. All over 6. So it's just a matter of plugging in our A, B, and C. I hope I did it right. So 8 plus or minus, all right, what's under there? That's gonna become a positive, so we're gonna end up adding because of the double negative. Did you get 184?
Yeah.
Now, don't get carried away. I know that 6 and 8 will cancel, but you can't. In a 3-part problem, this problem has 3 components. You cannot cancel unless you can cancel every part. And you never cancel under the radical. So no canceling at this point. Don't get carried away. What do we need to do at this point? Break down 184. So you'll do that however you want. I think I did that right. Remember, when you break a number down, it's no longer part of the problem. So I have 2, 2, 2, and 23. So out will come a 2. And in stays 46. Now you can cancel. see how you have all three parts have a 2 in common? A triangle, yep, the triangle of cancellation there. So we can cancel all three parts. So this is gonna become a 3, a 4, and a 1. So our final answer is 4 plus or minus 346 over 3. Now, what did I do there in that problem that was hard or scary? Everybody good? All right, would you try the next one on your own? Quadratic formula. You might want to try other methods, but you're supposed to be using a quadratic formula for this. Anybody want to come up and put it on the board? You can come up with a partner. Okay, Nate, great. You can come up, hi. Well, look, we're having a ball.
Oh my gosh,
Look how much fun they're having.
I see 1 smile, 2, 3.
Meg's gonna do a problem on the board real quick. Okay, right bigger than that, would you please?
Oh, sorry.
So the video will pick it up.
Okay.
So the first thing she did was distribute and move her 13 over. Does that sound like a good idea? Yeah. If she's using the quadratic formula, the equation has to be set equal to 0, so she did that. So she's got her A, B, and C.
Interruption. Is Brendan moved in the classroom?
I know I had him last period.
I'm sorry.
I had him last period. He's not in here now.
Thank you.
Okay, I'm gonna put Meg on pause. First of all, thank her for coming up and giving this a try. There's a couple things we need to touch base on. First of all, oh, you stuck it in. You got your plus or minus stuck in there. Okay, that's good. Second of all, look at your C value. Your C value was negative, which means that's gonna become a plus, which means what should be under the radical? 77, the best year ever. That's when I graduated from high school, 1977. And then we're done, right? Because 77 doesn't break down, and that's it. That's it. Thank you, Meg. Thank you. Okay, one more, and then we'll be done with this section. Let's talk about this guy. You have a couple of options on this problem. First of all, a lot of you don't like working with fractions, and I don't like to work with them if they can be avoided. So could we multiply everything here by 4? And then we would have an equation that looked like this. And there would be no more fraction to deal with. So that's an option. But I want to show you something to keep in the back of your mind. If I just stick with the original, I'm going to have 7 plus or minus the square root of 49 minus 4 times A times C. And because, all over to it, and because this fraction happens to be a 5/4, what's gonna happen right here when I times it by a
Cancel out
quarter
anyways.
inch? It's gonna cancel. So you can actually, in this problem, leave the fraction and not run into any difficulty. If that scares you, you don't know what I'm talking about, you don't care, you don't wanna do that, then go ahead and you can multiply everything by 4. The downside of that is, now you got big numbers, right? B squared is gonna be a big number. That's okay. That's all right, you can deal with it. All right, so what do we got here? Square root of, 44? Oh, I think that breaks down. 7 plus or minus 2 square root 11. Now, see these right here? Are you gonna cancel them? Nope, because if you can't cancel your triangle, don't cancel. You all right with that, guys? All right, let's get our calculators back out. And now we're gonna do some hard equations with our calculator. The other day, we kind of did easy ones because we were just getting warmed up, figuring it out. Now we're gonna do some harder ones. So, I can't remember what we did last, and I can't remember, I don't know what you've done. So would you do this for me to get started? Would you press your zoom button in the top row and 6 so that you have a standard screen? So zoom 6 will give you a standard size window, the normal regular window. Go to y equals, and if you have stuff in there left over, clear it out. So go to y equals in the top row and hit clear if you have any equations are still in there. Alright? Now, to graph an absolute value, listen carefully because you probably don't do this very often. On your calculator, you have a math button, right? I'm in y equals, hit y equals. Now, you have a math button. If you press math, it brings up a whole bunch of stuff. Go over to where it says number in the top row. The second entry there says NUM. And when you move over there, notice that option number 1 is absolute value. So press enter. And then type in 2x minus 1. That's equation number 1. So y equals, you got that in. Now go down to y2 and type x squared. So we typed in 2 equations. We typed in this side of the equation as y1 and this side of the equation as y2. Now press graph. And you're going to get 2 shapes, which makes sense because there's 2 equations, right? So here's what it looks like. You have a V, that's your absolute value, and then you have your parabola, that's your hope. That's your square. All right, everybody okay with that? The answers to the question are the 2 places where they cross. We talked about this the other day, graphing intersections.
I'm trying to help him use this calculator, it's just like, it's not. It's like every time I graph.
When you have this in a class, are you working on this? If I gotta pick one to start, I guess I'll just find this one right here. So, I got my graph here in front of me. I'm going to hit second, calc, and then go down to intersect. Because I wanna know where these two curves intersect. As soon as you hit second calc anything, but second calc intersect, the cursor comes up, move it over here, so left, take the cursor left, it will follow the V, so get it over here somewhere, press enter, then take it right, it will follow the parabola, get it down here somewhere, press enter, and then put it in between. Did you get negative 2.414? That's what you should have gotten for this x value. So double check, right? See if you can. So once we got a graph, we second calc intersect. Move the cursor, it will follow your first curve, it'll say first curve, it'll follow it, get it over here someplace. Hit enter, then it will follow this one, get it over here someplace. Press enter, and then move it in between those two. Press enter, and it should say this is your x value. How many got this? Okay. All right, let's try the other one. Maybe we'll get everybody to get this one. All right, so now we're gonna find this point. So second, start over, second calc intersect. Wherever your cursor is, you wanna get it on the V over here. So mine is flashing up here, so I'm gonna take it a little bit to the left and press enter. So I put my cursor about right here and pressed enter. Now, I need it on the parabola. This is my second curve. So I'm gonna set it up here. Press enter. And I'll put it between those two marks. I got 0.414 for that one. Anybody else get 0.414?
Yeah.
Good. Good. Okay. Now, we're gonna go ahead and start the next one. And I'm gonna come around and help those of you that are still on the struggle bus. Before we start this one though, do we all know how to cube on our calculator? So we've got a little button that looks like this, that'll take it to the third power. Also, since this equation is set equal to 0, when I get it put in, y equals, put it in, I won't second calc intersect, I will second calc 0, right? Because I wanna know where it crosses the x-axis. All right, go ahead and get started, I'm gonna come around and help. Anybody that needs help with it or the last one, either one, how are you two doing? You two are absolutely good. Where's your calculator?
Oh, I left that home, good now.
Well, God bless you, but we never go anywhere without our calculator, right? You don't ever leave your phone at home. Your calculator's right there with your phone, right?
I take
At
my
all times.
actions.
All right, you guys got this, getting this figured out?
Yeah.
Where's your calculator?
I'm on work tomorrow. I left mine at home too.
You must be thinking you were wonderful. You got it? You need to put that in. If you put it in, then you're gonna do second calc intersects, but you can just go ahead and second calc zeros. So option 2, when you second it, yeah, because you're gonna be looking for that one right there now. Okay. How about you guys? You guys okay? You're helping her do it.
It's 0, 0.
There's our phone. Okay, you gotta have a calculator. Their phone's supposed to be. Oh, over, not operational. Where's your calculator?
This is his, mine's in the budget.
Let's try to get a charge before class, okay? You guys are good.
Yeah, it's the left and the right.
Type in the equation.
You just said where's the
Press graph.
That's not. You haven't done it yet. Why
All right, how many x-intercepts or how many zeros did this problem have? Didn't this one look something like this? So how many times did it cross the x-axis? Once. Kids, when you set it equal to 0, you are looking where it is 0. Where does it cross the x-axis?
Right.
Right? Where was that point?
0.843.
0.843? That sound about right to everybody? 0.843? So that one had one answer, and it was 0.843. Okay, let's go ahead quickly and do the next one. Actually, we've already done an absolute value. Let's go ahead and do D. Let's do problem D. It is completely up to you. If you leave the equation like it is, you're gonna do what you did here. You're gonna graph it and look where it crosses the x-axis. If you like to do intersections, could you do this as one equation and this as the other equation? If you like to look where two intersect, it's completely up to you. The answers will be the same. So whichever way you want to do it. I think I'm just gonna leave it with the original equation. I saw some of you with a lot of gunk on your screen. Try to clear out the old ones so you don't have so much stuff to look at. I got kind of a Nike swoosh looking thing.
Yeah, it's.
I got this one.
Yeah.
And I got that.
Yeah.
So how many answers are there? One, and it's right here. So second calc 0, left bound, right bound. What'd you get? 2.828? Oh, shoot.
No, you're right.
All right. All right, would you get out your word problem sheet? We're gonna do a couple of word problems now. Or if you lost your sheet, you can pull up the book. Turn to page 51. And we're gonna do problem 60. On page 51, we're gonna do problem 60. Okay, so for problem 60, this is the picture they've given us. This is the building right here. This is the building. Here is my ladder leaning up against the building. They tell me this is X. They also tell me that the ladder is stable when the distance from the ground to the top of the ladder is 5 more than the distance from the building to the base of the ladder. So this is 5 more than this. So what's this? X plus 5? Now, boys and girls, you gotta get an equation out of this somehow. Who's got a thought on that? What?
Pythagorean theorem.
Exactly. Isn't this a right angle? You're allowed to make that assumption. We assume the building is perpendicular to the ground. So we have a right triangle. And anytime we have a right triangle, we can use the Pythagorean Theorem. And the Pythagorean Theorem says that leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. The only caution I have for you is this. This is a quantity, so when you square it, you don't square the x and square the 5. This is a FOIL, right? That has to be a FOIL. So you know how to do that first, outside, inside, last. And 8t squared is 324, I think. Yep. Okay, Jaden, are you keeping up here with this mess we got going on? What would be the next step, Jaden? What do you think? No idea? Look at this mess right here. You don't have any thought on what we might do with that?
Like the model terms,
Can't hear you.
I guess like combined terms.
Sure, absolutely. Yeah, don't make it hard. So we're gonna have 2x squared plus 10x. I'm gonna go ahead and subtract this over. So what is that? Negative 299. Yuck. Now what? Make?
The quadratic formula.
So we could use the quadratic formula. That would be an option. So x equals negative b plus or minus the square root of b squared minus 4. Oh, it's gonna be a big number, but I got a calculator, so I'm okay. I got 2492 under there. Is that by any chance a perfect square? No. I'm gonna rule this one out and say that's extraneous. What's that mean?
Yeah.
Extraneous? This is what we call an extraneous root. Can somebody explain that to Peter? What an extraneous root is? Have you heard that vocabulary word before? It doesn't check. We didn't make any mistakes, but it doesn't work in the problem. Tell me how I know, without even typing this in or anything, how do I know that answer cannot possibly work in this problem?
Your x can't be negative.
Exactly. Isn't this gonna be a negative number? I don't know what negative number it is, but isn't it gonna be negative? And x is this right here. Can that be a negative number? No. So I'm gonna go ahead and type this one in and see what that equals. When you type this in, please be sure that before you hit divided by, you hit equals. So you gotta work out your numerator and then divide it by 4. I got 9.98. That is not the answer to the question though. What does the question ask me? Yeah, exactly. Doesn't want to know how high up the building it's gonna reach. So it wants to know this right here. So the actual answer to the problem is 14.98. Read the question, answer the question that's asked. All right, we need to do 61, but we're probably not gonna get it done, but I'm gonna start it. So first of all, any question about this before I erase it? Mrs. Ford, how did you know to use the Pythagorean Theorem? When you have a right triangle, at least think about using the Pythagorean Theorem. All right, it won't work every time, but think about using it. Okay, let's look at number 61. We'll continue it next time, because I don't think we're gonna get it done, but we'll give it a shot here. We have this situation. And we know that the total area is 200. So the area of the whole thing is 200. Any thoughts on that? Well, isn't this picture 2 pieces? And this bottom piece is a square. What's the area of a square? Base times height, length times width, side times side. It's x squared, isn't it? What shape is this top piece? Half a circle, right? What's the area of a whole circle? The whole circle is pi r squared. So half a circle would be 1/2 pi r squared. Does that make sense to you? So we need, isn't this r? Right there, isn't that the radius? Tell me how long that is. 1/2 x. Or x over 2. Whatever's easiest for you. 1/2 x or x over 2. So the area of a half a circle is 1/2 pi radius squared. Whoa, write this down. We're gonna start here next time. And that has to equal 200. So here's the equation we're gonna solve next time. Okay, good job everyone. I will see you tomorrow. Okay, put your names on it so I can read it. All right, have a good day, people.
And also,